Hello, everyone. So today I'm going to go over with you a IB Math AA analysis and approach, higher level HL content, not the SL content. Between the HL and SL content of the IB Math, there are some question that is reusable in both exams, but this one is specifically for the HL content. For those of you who are in SL, you can watch the video also. Hopefully you can learn something as well, because this one has to do with very common, which is derivative, and the application of derivative, which is tangent line. Um, the only thing that separate this question from being an SL question is it involves a concept called implicit derivative. So today I'm going to show you how to attack and tackle this type of question, and how we can approach and solve this the right way. Okay. The question says, consider the curve defined by the equation. Here we have the equation x squared plus sine y minus xy equals 0. So usually this is an equation involving both x and y, mixed in terms of many things, right? Say find the gradient of the tangent to the curve at the point pi, right? So gradient of the tangent line is the derivative of the function, right? So what you need to find is dy over dx, right? So what I'm going to do is I'm going to apply the derivative with respect to x on both sides, right? Equals 0. So we're going to apply the dx over both sides, okay? D over dx to both sides. So this is what we have. D over dx of a constant is 0, right? So now we just worry about the left-hand side. X squared going to give us 2x sine y. Okay, so in here, y is a function of x. So for implicit derivative, I think I will make a separate video on that. So today we can follow along. Okay. Uh, Sine y derivative is cos of y, right? Oh, maybe I should move these over here so I can save myself more space. Okay, sine y is cos of y, but you must apply the chain rule, right? Dy over dx, correct? Right? Minus xy. So in here, the common mistake is usually you consider x, people just cancel x, and this is minus y. It is a not, right? You must apply the chain rule over here. Oh, sorry, the product rule. All right. So what you need is xy, right? So minus derivative of x is 1, right? Minus y. And then derivative of y is dy over dx. Okay. So next step is you're going to group all of the terms with dy over dx onto one side and all of the other term onto the other side, right? So I have, and this term is dy over dx, right? So we're gonna group it on the left hand side, and now I'm going to do it quickly. I'm going to factor also. So at this stage, if you feel like it's too fast, you can pause a little bit and watch or try yourself. How do I go between? How do I derive between the lines? Right. So here I'm going to factor out the dy over dx. Right. So I have cos y minus x. Right. Dy over dx. Correct. Is equal to every other term put onto the other side. So we have y minus 2x. Correct. Right. So overall, your now we just divide over dy by dx is y minus 2x over cosine of y minus x. And we need to find the gradient, so we need to evaluate the expression of dy over dx at the point pi, right? X equals to pi, y equals to pi. Okay, so I'm gonna substitute pi minus 2 pi, right? I believe it's pi. Let's check. sometimes you must check to make sure that you have the correct substitution. So pi minus 2 pi, here we have cos of pi minus pi. Okay, you want to separate this because sometimes I see uh, this is also a very silly mistake that I sometimes I see. Usually I see cos. People write cos pi minus pi. Then they cancel this one to be 0. Then the whole thing is cos of 0. It becomes 1. But it's not the case, right? So please avoid these mistakes. So pi minus 2 pi is negative pi. And cos of pi. So what's cos of pi? We have a calculator. So pi is over here, right? Cos of pi will be negative 1. Okay. And then we have minus pi. So this is correct already. If you reach this stage, you get the 4 mark already. Okay. But for me, I have a little bit of an OCD. So what I want is to make it look nicer. So what I'm going to do is multiply both top and bottom of this by negative 1. Then it will make everything positive, right? I will have pi over 1 plus pi. Now it looks much nicer. So we have finished the first question, right? Find the gradient of the tangent to the curve at the point. The next one, question B, this is an A. Question B asks you to show that tangent theta equal to 1 over 1 over 1 plus 2 pi, where theta is the acute angle between the tangent. This is the tangent to the curve at pi and the line y equal x. All right. So this question is worth of 6 mark. The first question is worth of 3 marks. So 6 marks. This question is very challenging. It asks you to find the angle between the tangent line and the line y equals x. So in here, you may want to do some quick plotting. All right. So the line y equal x, I know it looked like this, right? This is y equals x, roughly, right, on the x and y axis. All right. And we know that the other line is y. The other line, the tangent of the other line is pi over 1 plus pi, right? So there's one concept that you can see if an angle is like this, right? If an angle is theta, let's use another variable, not theta, but let's say the angle is alpha, right? Let's say alpha is the angle between a certain line and the horizontal axis, right? This tangent of alpha is actually equals to the gradient of the line, right? Because for any point, if you take any point, the tangent alpha is y over x, right? Y over x at any point, and the gradient is also y over x, right? So that is the case, right? And we know that tangent of this angle is 45 degree, right? Or pi over 4. And we know the tangent of this angle is equal to 1, right? And this guy is about roughly about 3.14 to over 4.14. So it's it's less than 1, right? So this guy is less than 1. So the angle is less than 1, correct? Oh, sorry. The angle is less than pi over 4. So again, we know that the tangent of alpha is equal to the gradient. So the other line, we know that it will look like this, right? It's smaller than the angle will be smaller than pi over 4. Okay, so it looks like this. And this is theta angle that you are looking for. All right. So how do we find this angle? What you can do is we know that theta angle is equal to pi over 4. Wait, this is not this is theta, right? The angle that we need to find is between the y equals to x and the tangent line. And let's call the angle between the tangent line and the x-axis is alpha, right? So we see that this angle theta is equal to pi over 4 subtract alpha, right? So we have tangent theta is equal to tangent of pi over 4 minus alpha, right? And in here, you need to apply some very rigorous trigonometry identities to do. Okay. So uh, tangent of a minus b, right? So you're going to look up the formula in the booklet. So this is equal to tangent pi over 4 subtract tangent of alpha divided by 1 plus tangent pi over 4 tangent alpha. Okay? And you see the tangent of alpha is equal to the gradient, right? So, and alpha is the angle between the tangent line and the x-axis, right? So therefore, my tangent alpha must be equal to pi over 1 plus pi. So we have every piece of information here. We're going to substitute in and solve, okay? And remember that they say show that tangent theta equals to 1 over 1 plus 2 pi. So for any question that say show that, right? It means that you have to solve, but technically they already give you the answer. You just have to work your way to the answer. Okay? All right. So here, tangent pi over 4 is equal to tangent alpha is pi over 1 plus pi, right? You do it slowly, step by step. You don't have to rush yourself, right? So here we have 1 plus tangent pi over 4 is 1, and tangent alpha is pi over 1 plus pi, right? So in here, I'm going to multiply both top and bottom by 1 plus pi. So to cancel the ugly denominator, this mini denominator, right? So I have 1 plus pi minus pi over 1 plus pi plus pi, right? Oh, so overall, the top I can cancel. I have 1 over 1 plus 2 pi. Oh, and lucky for us, we already reached the answer. Okay. All right. So that is it for today. So for more content like this, please follow the channel, like and follow. Then I can do more content like this for you guys in the future. Thank you.